Okay, so we're going to look at A-level trigonometry, and we're going to first split up and do all our rules on one page. Now, this is so important. Your differentiation, your integration, everything you do after this depends on it. So before we start looking at exam questions, let's sort of think about a summary of what we know. So from AS, we know that sine squared x plus cos squared x equals 1. We also know that tan x is the same as sine x over cos x, right? We know our trig rules and we know how to find sine, cos and tan of things, but let's remind ourselves anyway. Sine is 180 minus, cos is 360 minus, these repeat every 360, tan is plus and minus 180, and we also know that sine x is equal to cos 90 minus x. By that I mean that sine 30 is the same as cos 60. Right, so that's everything we learn in AS. And then we learn some new things when we get to A2. So when we get to A2, we introduce some new things. So we're now in A2, and we introduce 1 over sine, 1 over cos, 1 over tan. And we need to know what these are. And we don't have a button for them on the calculator, but we can work them out by flipping it. So we'll get cot x, sec x, and cosec x. And if you need a reminder, it's the third letter that matches. So these are the new things we've now learned. What we can do, and these are the identities that we're going to be using in the next bit that we do. We'll do the double angle formulas in another bit. We take that equation 1 and we divide it by cos squared x. Now, sine squared divided by cos squared is going to give you tan squared. You've got cos squared divided by cos squared, which is just going to give you 1. And then you've got 1 divided by cos squared, which will give you sec squared. And a way that you might remember this is 1 who is tanned is sexy. And we can also take this equation and divide it by sine squared. So when we do that, we'll get sine squared divided by sine squared, which is simply going to give me 1. I'm going to have cos squared divided by sine squared, which is the opposite of tan squared, so therefore that's cot squared x. So cot x we can also write as cos x over sine x. And then we'll have 1 divided by sine squared, so cosec squared x. So 1 in a cot is cozy. So those are my A2 identities. We haven't included the double angle formulas, and we've not done the area of a sector and so on, but we'll add those in as we add exam questions. So the first set of exam questions that we're looking at now is we're going to be looking at the trigonometry questions around sec, cosec, cot. So using these identities. So we've got 2 exam questions from the last few years. The first one here was from 2018, and we've got 4 sine x equals sec x. Okay, so first of all, generally, if you're unsure, you're going to change everything into sine and cos. So we know that sec x is the same as 1 over cos x. So we're going to have 4 sine x equals 1 over cos x. And so we're going to get 4 sine x, multiply that up, cos x equals 1. Right, turns out we do need our double angle formulas. So let's go back and write those in as well. So our double angle formulas, for the moment we're just going to learn them. We'll do a separate sheet where we go through where they come from. Is we have sine 2x is 2 sine x cos x. Cos 2x is cos squared x minus sine squared x. We can write cos squared as 1 minus sine squared. So we'll get 1 minus 2 sine squared x. And then we'll get 2 cos squared x minus 1. So there's 3 different ways to write cos 2x. Okay, the reason I put that in, because in this question, we've got 4 sine x cos x. Now, we know that sine 2x is 2 sine x cos x. Therefore, 4 sine x cos x must be equal to 2 sine 2x. So now we've got 2 sine 2x equals 1. Therefore, sine 2x equals a half. And then we look at what our range is. And if we can see, our range is in radians. So it's between 0 and pi by 2. Now remember, pi by 2 is 90. So we want a range for 2x. So that means 2x must be between 0 and pi. Right, including pi, just 0 and pi. Okay, so in my calculator, in radians, so the minute you see this question, you're going to switch your calculator into radians. I'm going to do inverse sine of a half. And when I put it into my calculator, I'm going to do shift sine of a half. It's going to give me pi by 6. Okay, then I think, what was my rule for sine? So from AS, I know my rule is 180 minus. Now in radian world, 180 is pi. So into my calculator, I'm going to do pi minus answer, and it's going to give me 5 pi by 6. I now know for each of those numbers, I can add and I can subtract 360, so 2 pi. However, my range is only one cycle. It's only going up to 180. It's not even a whole cycle till 360. So we're going to stop there. And we are going to divide by 2. And we'll get 5 pi over 12. And that's how you do that question. Right, let's have a look at the next one. So the next one is similar again. We've got part A, which is a show that. Like we said, if in doubt, change everything into sines and coses. So we're going to take the left-hand side first. Cosec theta, from our rules, is 1 over sine theta. And then we've got minus sine theta. And whenever you see a fraction like this, you're going to make it into one fraction. So I'm going to put sine theta on the bottom. The 1 doesn't need to change, and I get sine squared theta. Hopefully you'll recognize that as cos squared theta. And then you're going to look at your answer and go, what am I trying to get? I'm trying to get cos theta multiplied by cot theta. So I said, well, this is the same as cos theta multiplied by cos theta over sine theta. And I'm there. So cos theta, cot theta. Right. The next bit of the question says hence or otherwise. When you see that, it's always hence. You're always using what you've already done. So for part B, you're going to have, well, let's see what the connection is. We can see that this effectively matches up to this. So we can replace cosec x minus sine x with cos x cot x. Okay, so what does that give us? We now have cos x cot x, and that equaled on the other side cos x cot 3x minus 50. Now you might be tempted just to divide the cos x away and say we don't need it. You can't do that because it's a function. You have to consider that it could be 0. So you can get rid of it, but only if you consider it could be 0. So what you have to say to yourself then is cos x could be 0, and then you can get rid of it, and you're left with cot x equals cot 3x minus 50. Now if cos x equals 0, the range we're going for is between 0 and 180. The only place that cos x is 0 is 90. And so we'll put that there. We're back in degrees, as you can see. Right, Now, if we take cot x away from both sides, we're left with x equals 3x minus 50. So I could rearrange that. I get 2x equals 50. At this point, I'm going to stop because I know that cot is 1 over tan. The same way that tan repeats every 180, so does cot, because I could flip them both and work out what tan is. So we've got 2x, so we're going to increase our range. And we're going to do 50 plus 180, which is going to give us 230, and now we can divide by 2. So a lot of students didn't get the second solution here. It's fine, but you'd have lost 2 of the marks there. So those are a couple of examples where we've got cosec, cot, and sec. We'll look at the double angles and we'll look at a lot more of the more modeling trig functions in the next session. Hope that was useful.